So hi everyone. Okay, in the actual context, we have problem with security with an Android, and I'm going to present you Android permission because I want to show you how the system interact with the permission you're setting in your apps, and how, if you don't use them, how it leads to a security hole. So I will already be presented. I'm part of Genie Mobile company, and I'm an active developer in Genymotion product. So feel free to come to see us and talk about Genymotion. We're downstairs and we have a stand, and you can talk to us about it. So I am a system developer, right? I do not dev any application. So I'm here to explain you how it works and how your permission is influence the systems. So what is a permission? Generic definition. You have the authorization to do something according as a law, a right, or a rule. It's in order that you protect something. Okay, that's the generic definition of anything. So, please. Okay. So, who is aware about Linux-based system? Please, people who raise their hands. Great! So I can be very fast on this part. So, okay. So you know that under Linux, users are defined with IDs, and these users are included in group, also defined by IDs. These IDs, oh, no, go away. One of the main ID, which is very important, is the zero ID, because it's a super user. And when you're a normal user, you have an ID other 1,000 on Linux, according to the standard. Okay? These users and group give you permissions. These permissions are separated in three kind of team for file system on file system. You have the owner permission, you have the group permission, and you have the rest of the world permission. Is here. You can see here the first letter is the owner, the three left is for the group, and the three last letters is for the worldwide. These different permission groups have its own action: read, write, and execution. That's what I'm showing right here. So, of course, we don't display ID when you're listing a directory. It's absolutely not user-friendly, so we show the name. So, of course, here I have, so this me, I'm in the Genymotion, Genymotion directory, and over here, where is my pointer? Over here, I have the read-write execution on the binary of Genymotion. And as root, you see that all the rest of the world, including me, I'm not able to read, write, or do any execution on this file. All right. So what about the process? You have to understand that the file and the directories are attached to your group and users, but also your process. A process is have its own ID. When you run a program, you have its own ID, but it's attached to a user. That's what I'm showing here, just here. So the process has the same right as the user who launched it. So if the binary wants to do an access to a file, this file has to be on the same user and group than the program. Okay, so that's what is run under Linux. Is to protect file system and running programs. There is other protection system in Linux. There's selinux and capabilities. selinux is more grain permission system. I won't go further in this one because it's a self-talk about it for like 1 hour. And capabilities in the other way to, okay, I have a program, for example, who I want to mount my hard device. If I just do it in this way, I need to be root to run this program because I don't have the permission to do it. So the capabilities is something you set in your in your program said, I want the capability to mount the device, then when you're going to run your program, you will be able to run it as with your own user. Okay, so what's going on Android? On Android, it's something very special because when you have a device, Google realized that there is only a physical user of this device. Even now we have multi-port support. I won't talk about it because we don't have time. But at the beginning, it was only physical user on your device. So that means all the application you're going to run was only on the same users and group permission, and said, not really well, because if an application is doing something wrong, then it have access to the data of the others, and not very secured. So the idea is, okay, the application will have its own user group, user ID and group ID, all right? So how it's work under Android, there are different range for the UID. For the 1,000 user ID will be for the system part, for daemons, and up to 10,000 it will be for the application user ID. These values are the same. They use the same values for the GID for the groups, okay? But and that is when you can see there is a file under in your system which store the UID of your application and the GIDs. So let's go further. Okay, but sometimes when you're developing an app, you use a very special option called Share User ID, which means that, in fact, in the system, the implication is that all the application using this option, they will have the same user ID. So if you say the same user ID, for example, as system, your application will have the system user ID. This, for example, what you can see. For example, the user dictionary and contacts, they have the same user ID, so that means the application have been declared with a share user ID option. So, it's the way it acts on the file system is exactly like on the Linux. So, of course, here, as you see, there is a name, is not the user ID, because the ID is mapped to name to be more friendly, of course. The application user ID is determined at the when you install your application, right? And of course, at the installation time, your application will have its own directory, a dedicated directory. So, for example, I take the calendar application and say, okay, this is your directory, and you have this right on it. So, as you see, you have the execution, write, and read-write execution in this part of the file system. Okay, what about system application or system daemons? They have to be statically defined to be sure that from a device to another, it won't change. But for your application, as is determined at the installation time, this ID the app's ID will be generated with a signature. So that means when you install an application on your device, the UID won't be the same as your colleague device. We have another ID because it's generated with the signature. Okay. Come on. No. Okay. So, at the beginning, your application is sandboxed. It's self-contained. In this way, your application don't do many things. And what you want to do is that your application can talk to another application. And sometimes you will have to do that. You need some permission. And the permission you're using in your application when you declare it in your Android manifest. So, but we have to keep the system secure. So that's why Google gives you the means to do it. And when you install your application, everybody knows that your application is you grant the permission at the installation. But hello, oops. So You know in Android manifest how it works, right? For example, you put in Android manifest the permission you need. For example, I want to access to the vibrator. So that is a permission. And these permissions are a predefined permission that the system gives it to you. It's already defined in the system. And you can find it in the source tree at this path over there. But you have also the means to do your own permission. And I do recommend you to use them. And you'll see later why. So how is defined a permission? The very main thing is defined by a name, which is a string, permission group. Okay, this one is going in this group, and this group gives you the JID, right? And you have the protection level. Is it normal, dangerous, or not? Normal. You know that in normal levels, the system won't wait for the custom validation, the user validation to grant the permission. You don't see it at all. You will only see the permission to grant the permission to free over level. Okay. So now, okay. So for example, some of the permission is asking to access for your SD card storage, right? And is considered to be very dangerous. And that means if you are a normal application, you need to have higher privilege to get them. And in this, for example, writing to the SD card, you need to, the system provide you to what we call a GAD mapping. At the installation time, you're going to we'll see later, you're going to parse your Android manifest XML, right? And then realize, oh, this guy wants to write on the SD card. And in the system, we said, but this permission, I need to have higher privilege to do that. So you have a file in your system said, for this permission, I need to map this permission to a specific GID, because this GID have higher privilege, and the application will need it. So it will add this GID to your application, and this is what you have here. That's the GID for higher privilege. And I think, like for the SD card, for example, this is the GID for writing and reading on the SD card. So we see that, okay, everything is managing about UID, GID, but what happened in the lifetime of your application? So first of all, of course, the first thing you want to do is to install it. So, for example, MMS application, you want to install when the package manager. The first step of the package manager is doing is say, okay, I'm going to parse the Android manifest XML just to watch what the permission the application do need. So, after that, it's going to fix the UID for your application with the signature. Okay, so you have a unique UID, and because, for example, MMS, you can store some message on your SD card. You will have mapping GID that we saw just before, and the package manager stores a database, okay, where all your application is listed. It contains all the information about your application. The UID, of course, the signature, the certificate signature, what else? Permissions, of course, sorry. And so each time you install an application, the database is updated and stored. System package list is a file where they store only the UID and the GID needed by the application. Okay? So here, so all the information about your Android permission is stored in a database. But when you started an application, how an application is started on Android device, some of you may know that at the startup of your system, you have an init file which will have a PID1 and have root permission. So mean the GID and the UID is 0, 0, right? And for the application the init will launch the Zygote service. What is Zygote is a program. This program is the Dalvik GVM, which contains the preload libraries from the framework and the core Java libraries. And if it's init to launch Zygote, that means that Zygote do have root permission for the user and for the group. But what we want is that our application has its own UID and GID. So what it's doing, like on the step, on the step 2, Zygote received say, I want to start the application. Zygote on the step 3 going to fork the Zygote. Then the application has its own Java environment Java runtime. But at this step, your application has the root permission. And what's happened just after the fork, the system sets and save the UID and the GID for your application according to have been declared in the database we saw just before. And then when you have finished that, your application has a good user ID and write ID according to what you declare in your Android XML file. So at the end of the process, everything is fine. The UID and GID are correctly set. So let's see how it happens when you're running an application like MMS. And for example, when you receive a message, most of the time your device is vibrating because MMS can have access to the vibrator. So let's see now in the system deeply how is happening and when your permission is granted or checked, or when your permission is enforced in the system. So in the framework, it does exist a representation of the vibrator. It's an abstract class, okay? So what we want to do to find is this famous vibrate function, right? Here. This function is using an abstract function, and as you see here, there's something very interesting. This is asking for the UID. It's what we're going to try to find in the system. So let's go. Act 1. I just received a message. Okay. So in the MMS application, you have a notification, a messaging notification, and you're going to check in the preference activity if you ask for the vibrator, because on the MMS, this information is stored in the shared preference. So he's going to check, does the user ask for vibrating at the incoming message? Said in our case, of course, yes. And he said, okay, so I will build my messaging notification, and I send it to the notification manager. He said, okay, now I will send. The manager is aware that the notification is pending, and he will say to the notification services that, hey, you have to treat this notification. Here, for your is a huge shortcut in the notification manager because a lot of things are happening. But at the end, when the notification is treated, you access to vibrator service. Vibrator service is a system daemon, right? It's run in the same process that the system server, okay? And so when this process is running, it has system permission. So what happened in vibrator service? Some code. Okay, in vibrator service said, oh cool, I have my vibrate function. asking for a UID and everything. And as you can see, on the first, at the top of there is here that your Android permission is checked. So it asks that this is if this checking the context that to see if in checking the context that does the Android manifest permission is okay, and it have been granted also in a package manager to check that. If it's not, the system is raise an exception. And after it said yes, it's okay. The context do have the permission to do it. Okay, but that's not enough at all to see to be sure that your application can access the vibrator. So what I need to do is to verify the UID of the incoming process, of the calling process. So what is doing here is in the other part of the code. You ask the binder. Does everyone know what's binder in the Android system? So binder is the IPC system. It's the interface that your application use to communicate between each other for sharing data, sending message, and all that stuff. So you have to ask the binder. Said, can I get the calling UID? Can I get the calling PID? If are they okay? Do they match? If they match, okay. Now you are able to enforce the permission to access to the vibrator. So you are at the framework level, right? And for this example, is how your permissions is enforced. There is different. The enforced permission can be at different level. It can be in the kernel space. It can be in other levels, but in our example, is done in the framework level. So what happened? Because, okay, cool, I have the permission to do it, but you don't have yet access to the device. So you say the binder here tells, okay, you have the access to the stuff. So go back in vibrator service, and then in the function you will call vibrate for millisecond, and this vibrate will load a GNE library. In this GNE library, you have the C code because, of course, vibrator is a device. So which means that you need to go in the C world. You have a Java world, the C world here, so you have to use GNE to say, okay, I want to vibrate for X seconds. And then you will be able, that's why you are able to access to your vibrator and vibrate your phone as a notification trigger. So you see all the process running in your system just to enforce a permission, but just declare it in a simple XML file. And as far as you know, is that this permission for vibrator is a normal level. So this permission haven't been granted by the user. So just can imagine what happened when you use other level groups. It can be definitely more complicated. Okay, now we're talking about security. You know, you see a bit.
I'm sorry, may I ask a question? How long will you? Okay, you're running out of time. You have already run out of time.
Okay.
How long will this take? This use case?
Okay, I can switch that if you want to. I just go into the end.
I can give you, if we refrain from asking questions, I can give you 2 more minutes.
Okay, 1 minute will be enough.
Okay.
Just I want to show you is that one guy in. Okay, give me. So this was an example of when you're not using correctly a permission. Don't use a permission correctly. And I just want to show that what was the beginning. The beginning was okay. The guy was in the application declared a receiver, and for this receiver, for one action, you have a permission to do the action, and on the other action, no permission. And the first action, what was doing is to do a shell command on your device, pop a shell command, and what happened is it was not protected by an Android permission, right? So anybody who use was able to pop it using ADB AM command. ADB AM command. So that's why here you need, when you you perform an action with which have and also this application had the share ID with the system, the UID system user. So that means you are able to do a shell command with a system user permission. As a conclusion, I just want to talk about Android M because it just happened last week. It seems that Google have refactoring all the system. I'm not sure yet what is going on exactly because they don't have the time to see it. But I'm aware that all I have presented you may change a lot. So in the Android M, it's going to be really different. So I hope I will do a talk later about it. I'm sorry it take a long time. Thank you for being here. It was like my first talk in English and first talk in Joy-Con, and I hope you enjoyed it as much as I did.
Thank you, Alizée.